All right, our example today is how to solve a system of equations when we have three equations and three variables. So the equations that we're going to look at today are 2x minus 3y plus 2z equals 2, x plus 4y minus z equals 9, and negative 3x plus y minus 5z equals 5. So we have three equations, three variables. Since we have three equations, that means our matrix will also have three equations or three rows. So I'm going to put my variable names up at the top so I stay organized. There's my equal sign, and I'll have my constants over on the right side of the matrix. So start by listing all of the coefficients in the first equation. I had 2x, negative 3y, and 2z, and this was equal to 2. In my second equation, I had 1x, 4y, negative 1z, and this was equal to 9. And in my third equation, I had negative 3x, 1y, negative 5z, and this was equal to positive 5. So I have set up my system of equations, or set up my matrix for this system of equations with three equations and three variables. So like I said, we had three equations. That means we had three rows. The rows are the horizontal numbers that run across our page. And then we have four columns, a column for x, a column for y, a column for z, and a column for our constants. So this is said to be a 3 by 4 matrix, 3 rows and 4 columns. Our goal for this matrix, to solve this matrix, is to end up with something that looks like this, where we have ones in the diagonals, zeros above and below, and we still have some constants over on the right side of the matrix. All right, since we've been practicing our matrices, we know that we have three operations we're allowed to do with matrices. We can switch rows, we can multiply by some number other than 0, and we can also add a multiple of one row to another row. We're also going to be using our graphing calculator today. So I hope you have the programs that I'm going to use in your calculator. If not, you need to come see me so we can get those put in your calculator. But step number 1 does not require a program, and that is that we actually enter the matrix into the calculator. So we're going to hit our second button and this x-1 button, and it'll bring up the matrix editing window. Use your over arrow keys to go to edit, and the first thing we'll need to do is list the size of our matrix. So hit 3 enter and 4 enter. It'll expand your matrix if it wasn't this big already, or shrink it if it was too big. And then we're going to start entering in our coefficients from the matrix. So I'm just hitting each number. It'll go just like we put them in. It'll go down the row. And then once we're done with those numbers, it'll go to the next row and you can input your numbers. And after each number, I'm just hitting enter to move to the next number. And if you're looking at your matrix and notice you've made a mistake, all you need to do is use your over arrow keys or use your arrow keys, and you can go adjust the numbers within your matrix. Now hit second quit or second mode to get out of that window. And we're going to turn on our program ROWOPS. So hit this program button and either type in the number for ROWOPS or go down to whatever number ROWOPS is and hit enter. Now it's going to bring up that matrix, hopefully the one that you just typed in that we're going to be working with. So look at the matrix on your screen, look at the matrix that you have written on your paper, and they better match. If they don't match, we're going to have to go back out of this, go back in to edit our matrix, because we don't want to continue with the matrix that has the wrong numbers. I promise we won't come up with the right answer if we start by using the wrong numbers. Okay, So every time we were solving a system of equations using a matrix, we start by looking at the columns. So look at the first column. What we need is a 1 up here on the top and zeros below. So our first goal is to take this 2 and turn it into a 1, using those 3 operations we're allowed to do with matrices. Now I'm not going to talk about how to swap rows because we don't use it very often. I'm going to use the last 2 operations where we take a non-zero multiple of one row and add it to another row and multiply by some number other than 0. So I'll start by asking you, is there a number that we can multiply with 2 to turn it into a 1? And the answer to this always is yes, the reciprocal. Reciprocals will always turn our numbers that we want to turn into 1s into a 1. So what is the reciprocal of 2? 1/2. So the first thing that we'll do is take 1/2, multiply it with row number 1 to create a new row 1. So we can do all of these things in your calculator. You don't have to do any of these calculations by hand. Option number 2 there says to multiply. We'll be multiplying row 1 by 1/2. All right, so in your calculator, this was to multiply row 1 by 1/2. That was the reciprocal that the reciprocal of 2 to get a 1. So our new matrix looks like 1, -3/2, 1, 1, 1, 4, -1, 9, and -3, 1, -5, 5. Okay, our next goal is to turn this number into a 0, right? So we're in this column, we've got a 1s, everything else we're trying to turn into zeros. So the trick to turning into a 0 is always going to be opposite sign of the number we want to change times the row that has the 1 in it plus the row we want to change to create a new changed row. And while we're at it, let's go ahead and turn this -3 into a 0. So is there anything I could multiply with 1 and add to -3 to get 0? There certainly is, +3. So we're going to do 3, which is the opposite sign of -3, times row 1, our row that had the 1 in it, plus the row we wanted to change to create a new changed row. Now in your calculator, this is all under the to pivot function. However, to use the pivot function, we need to tell our calculator which entry needs to remain a 1 because everything else is going to turn into zeros. So the thing that we want to leave as a 1 is this number in the upper right hand corner. So that is, we want to pivot around row 1, column 1. Now these pivot positions will always have the same numbers: row 1, column 1, row 2, column 2, row 3, column 3. So those numbers should match up when you're doing your pivot function in your calculator. So choose option number 3 to pivot around row 1, column 1. So I'm just hitting 1 and enter after each one. And that gives us a new matrix that looks like 1, -3/2, 1, 1, 0, 11/2, -2, and 8, and 0, -7/2, -2, and 8. So this is what our new matrix looks like. Okay. So the next thing that we need to do is to turn this 11/2 into a 1. Because remember, every time we start a column, we're working in, every time we work in our columns and start a new column, we start by getting the 1. And then we start by getting the 1, and then we work on getting the zeros. So how do we turn this into a 1? We multiply by the reciprocal. So the reciprocal of 11/2 is 2 over 11, and this is row 2 where we need this 1, so this will create a new row 2. In your calculator, this is to multiply, and we'll be multiplying row 2 by 2 over 11. So choose option 2 to multiply row 2, hit enter, by 2 over 11. So our matrix now looks like 1, negative 3 halves, 1 and 1. And 0, 1, negative 4 over 11, and 16 over 11. And 0, negative 7 halves, negative 2, and 8. Now, if you can't see all of your numbers in your calculator, if you can't see all the numbers in your matrix, use your over arrow keys and you can scroll back and forth and you can see all of your matrix. So I'm using the over arrow keys. I can see all of the matrix. Okay, now that we've turned this into a 1, we need these two numbers to turn into zeros. So the trick for getting a 0 is always opposite sign times the 1. So the opposite sign of negative 3 halves is positive 3 halves times our 1, which is in row 2, plus that row that we wanted to change to create a new changed row. And same thing here, how do we get a 0? Opposite sign, so 7 halves times that row that has the 1 in it, plus the row we wanted to change becomes a new changed row. And in your calculator, this is taken care of under to pivot. And we'll be pivoting around row 2, column 2, because that's where our 1 is. So in your calculator, hit enter, and option number 3 to pivot around row 2, column 2. So our new matrix looks like 1, 0, 5 11ths, and 35 11ths, and 0, 1, negative 4 11ths, and 16 11ths, and 0, 0, negative 36 11ths, and 14 11ths. Okay, so we're almost done. All we need to do is take care of this last row, or this last column, sorry, this last column. So we've started a new column. The first thing we're going to do is get a 1. So we need 1s in the diagonals. How do we get a 1? We multiply by the reciprocal. So the reciprocal, or flip fraction, of negative 36 over 11 is negative 11 over 36. We don't change the sign, we just change the fraction itself. So multiply that row by its flipped fraction. So in your calculator, this is going to be to multiply row 3 by negative 11 over 36. So option number 2 to multiply row 3 by negative 11 over 36. This makes our new matrix 1, 0, 5 over 11, 35 over 11, 0, 1, negative 4 over 11, 16 over 11, and 0, 0, 1, and negative 4. Our last goal is to take these two numbers and turn them into zeros. And the trick for turning into zeros is always opposite sign. So the opposite sign of 5 over 11 is negative 5 over 11 times the row that has the 1 plus the row we want to change, new changed row. Oops, those are 1s. Same thing here, we want to turn it into a 0, opposite sign times the row with the 1 plus the row we want to change, to get a new changed row. And in your calculator, this is to pivot around row 3, column 3. So in your calculator, bring up your commands. We're going to do option number 3 to pivot around row 3, column 3. So that gives us a new matrix that looks like 1, 0, 0, 5, 0, 1, 0, 0, and 0, 0, 1, negative 4. Now that we're finished and we have it in Gauss-Jordan form, what we can do is we can read the answers to this system of equations directly from the matrix. So our top row says x is equal to 5. Our second row says y is equal to 0. And our third row says z is equal to negative 4. So the solution to this system of equations is 5, 0, negative 4. It's called an ordered triple. I hope this helps.